2013, question 3. Right, well, first of all I can see that this is clearly a parabola. Parabola, spell it right. And that means it's to do with x squared, a quadratic equation. Needs to model this. Right, write down the intercepts with both the x and y axis. So let's start with the x intercepts. Here's the x-axis. This is where the graph intercepts the x-axis. Now we need to make sure someone knows what we're talking about. There are two of them, and they need coordinates. So here is one of them. That's the point -5, 0, and that's the point 1, 0. Now the y-intercept, where the graph intercepts the y-axis, once again it's a coordinate point. It intercepts at the point 0 on the x, up to 5 on the y. Right, we might need to leave the graph here. Now of course we need the equation. For a parabola, if we're going to use the calculator, we need 3 points. Well, I've got my 3 points. The most important thing, of course, though, is that you can write them now in a table and get them the right way round. Right, so over to the calculator, and we want to go into the stat menu. We're going to put the points in, so -5, 1, 0, and over to the other side, the y values, 0, 0, and 5. Right, hovering over F1, graph 1, calc, and it's a parabola, so we know to choose x squared. There's the general form, and there's a, b, and c to put in the equation. So y equals ax squared plus bx plus c. Copy that down first. Now using x and y is okay because this is not a practical graph. A is -1, so we could write that as -1x squared. B is -4, and c is 5. So that's the equation of the parabola. Right, next question. We might need to keep our graph here. The graph above has moved 1 unit to the right and 2 units down. Write the equation of the new graph and give the new y-intercept. So take the points we've already got. We're going to move them 1 to the right and 2 units down. So if we take this point, we're going to go 1 that way. Just watch your scale here, because it's quite large that way, and this is actually in 1s down here. So 1 this way and 2 down to there. We might just note these new points as we go. So this new point here would be the point 2 on the x down to -2. And then this point here, 1 to the right and 2 down. So it will be through that. So that's the point 1, 3. And if we move this point across 1 and down 2, that would be the point -4, -2. And then we could join it up. We could take the vertex across 1, down 2. It doesn't actually say to draw the new graph, but I think we'll draw it in so you can see it, how it's moved. Like that, so that's the new graph. And we're asked to give its equation. So we've got the numbers here. We just need to put them into the points, put them into the calculator. And choose graph 1, calc, and it's quadratic. Make sure it looks approximately like what we've got. And there's my new equation. Now we just have to move down a bit here. So we get y equals ax squared plus bx plus c, which is the general form for all quadratics. -x squared minus 2x plus 6. And of course the good thing is that both those rules have the negative in front of the x squared because it's an upside down parabola. So we were expecting the negative for A. Right, now it did also, before you rush on, mention to give the new y-intercept. Now when you have a y-intercept, then that means that the x-coordinate is always 0. If you look back up in our graph, it's a bit hard to see where that x and y-intercept is. So if we put x equals 0 into this rule here, we'll get y equals negative 0 squared minus 2 times 0 plus 6. And working that out gives me y equals 6. You could go back and have a look at the graph and just see whether it looks like the y-intercept. Now I haven't drawn it very well here, but of course if you were counting for a parabola, from the vertex we need to go out 1, down 1, so it should have gone through that point. And similarly out 1, down 1, out 2, down 4 to get good shape, out 2, down 4 to get good shape, like that. Alright, so we've answered all the pieces of that question. We've got a rule and we've got a y-intercept. There are other ways to answer these of course as well. Next question, here's another parabola. It's in factorised form, y equals x bracket times y equals x times 4 minus x. Now I know that it's going to cut the x-axis at 0 and positive 4, but you can plot some points. So we could put this into table to plot points, or you can work it out by hand. Choose any x value you like along here. If we go over and use table, and we put in x times, remembering to put the times in and then the brackets, and we'll set that to go from about negative 6 up to 6. And there's some points. Now obviously if they're too big we can't plot them, so let's find something we can plot. Negative 1 goes down to negative 5. 0, 0. 1 maps onto 3. 2 maps onto 4. 3 maps onto 3. So there's the symmetry happening. 4, 0 as we predicted. 5 onto negative 5. And we can get a good idea of that now, joining it up to look like a parabola. Once again it's upside down. We might ask ourselves where the negative is. If you were to expand this equation, you would get y equals 4x minus x squared, and there's the minus x squared turning up, so we know it should be a negative parabola, and you can see the minus x in this bracket too. Now a horizontal support for the design is placed 5 units below the x-axis. 1, 4, 5, so down here we're going to put a horizontal support in. What is the length of this support? You must solve an equation or give algebraic support for your answer. So I can see that the length of that brace is going to go from negative 1 to 5. It's going to have a length of 6. So I know the answer is 6. But we need to use some algebra, solve an equation to find out y. Right, so finding the length of this line by solving an equation, what we want to do is, with the equation x 4 minus x, we want to find out when that equals negative 5. So there's an x value here and there's an x value here. I know I can see what they are, but this is using algebra to prove it. So we've got a wee equation to solve. 4x minus x squared equals negative 5. Now this is a quadratic equation, and the rules for solving quadratic equations, we need to get 0 on one of the sides. So I think to make this easier for ourselves to solve, we'll try and get 0 on this side. To do that I need to add x squared to both sides, and I need to subtract 4x from both sides. What you do to one side you do to the other. So I'm going to end up on this side. We'll put them in the right order. X squared minus 4x, and I've still got the minus 5 on this side. Solving a quadratic equation. Next step, factorise. We need to get negative 4, so we'd need negative 5 plus 1. You can check, of course, by re-expanding over here. And solving that equal to 0, either you need to find an x value that makes this bracket 0, or that makes this bracket 0. And I can see that clearly negative 1 substituted into this equation would get 0, and substituting x equals 5 into this equation would get 0 as well. And of course they're the answers I want, negative 1 and 5. And just a sentence to say, therefore the brace would be 6 units long. You might need to do some revision about solving quadratic equations. Right, and quickly on to the last part of the question. Got an arm wrestling competition. We enter 1024 people. 2 people arm wrestle, the loser is eliminated. And so if you have 1024 people and they play against each other, 1024 divided by 2 would mean I'd have 512 games. And, oh, this is people, so at the end of round 1 there'll be 512 people left. At the end of round 2 we'll have half that number, so 512 divided by 2 will be 256, and half of that 128, half of that 64. And you might like to keep going actually, because it says how many rounds are there in the competition. So this is the first round. We have 512 games, and obviously there'll be 512 winners that will move on and play each other. Half of 512, there'll be 256 games as they play each other. Each game has a winner, so there'll be 256 winners that will carry on to the next round. I'm just going to squeeze in 32. Half of 32 is 16, 8, 4, 2, and 1. Alright, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rounds to find the winner in the last one. Now write an equation relating P, the number of people left in the competition, to the round number. So because we're dividing by 2, I can see that this has something to do with powers of 2. I know it has something to do with powers of 2. We might look at the gap each time as we try and work out the rule. We could have a go at writing it down here, just to check whether it's linear, quadratic or exponential. Looking at the gap between that one and the gap between that one, and then looking at the gap between these, 256 minus 128 is 128. The gap between this one, 64. The first difference is not the same, so it's not linear. The second difference is not the same, so it's not quadratic, which tells me that it must be an exponential rule. And I know I need to use powers, and in this case it would be powers of 2. So 512 here, 2 to the power of something. I know that 4 is 2 squared, 2 cubed, 2 to the 4. 2 to the 9. So we need to have a look at the power and see how it relates to the round number. It's the power, look at how it relates to the round number. 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10. So if I know the round number, 10 take away that round number would be the power. So P would equal 2 to the power of 10 minus the round number, which we're letting be n. So just think about that. So if we want to know how many people are left in the 5th round, it would be 2 to the power of 10 minus 5, which is 2 to the 5, which in this case 32 would be correct. So that's just checking that we agree with that rule. Okay, and now we need to graph it on the graph below. I'm going to lose my numbers. So at the end of round 1 we have 512. Probably need to check the scale here. 2, 4, 6, 8. Yep, so we're going up in 20s. 40, 60, 80, 100. Now at the end of round 2 we've got 128. At the end of round 3, oh no, I missed one, 256. It's because I can't see. Sorry, at the end of round 1 we had 512, in the round 2 is 256, 20, 40 up there, and then 128, 64, 20, 40, 64, 32, 16, 8, 4, and so on. So joining these up, it would of course have a y-intercept. It would have a y-intercept up there of 1024. So before we'd played any rounds, 0 rounds, 1024 people. So there's my exponential curve. Right, and moving on to the last question. Exactly 1,000 people enter the competition. How would the competition process need to change? So if we had 1,000 people initially, then that would mean we would have 500 games and 500 winners in round 1. From those 500 games, once you have 500 people, you'd have to have 250 games, 250 winners, 125, and then of course you have a problem. Because if you have 125 winners, you can't, therefore, you'll have to start introducing a bye where one person doesn't play. Introduce a bye where one competitor doesn't play that round. And the reason is just because of halving, you end up with the odd number.